Welcome to today's Statistics and Probability lecture. Today we're going to be looking at how to solve conditional probability problems using Venn diagrams. Let's look at this conditional probability example. 300 students are enrolled at the university. 200 students are enrolled in English, 100 students are enrolled in math, and 50 students are enrolled in both English and math. What is the probability of being enrolled in English given the student is enrolled in math? We can use a Venn diagram to help us solve this problem. So let's first fill in the circles of our Venn diagram. We have 200 students are enrolled in English. So let's put our 200 English students and label this yellow circle English. Then we have blue, we have 100 students that are enrolled in math. So we'll put 100 and label the blue circle math. And then we have this green intersection for the students that are enrolled in both math and English. And we see that we have 50 students enrolled in both English and math. So that's going to be 50. So we want to know what is the probability of being enrolled in English given the student is enrolled in math. So before we solve that, let's just look at the probability of each of these events. So the probability of English is going to be our 200 that we have here in the yellow divided by our 300 total students. And that can simplify to 2/3. Our probability of being enrolled in math is going to be 100 divided by the total number of students. So we're going to take the number of the element, divide it by the total number, so that's going to give me 1/3. And the probability of being enrolled in both math and English we can see is this intersection, so we can take that 50 and divide it by the total number of students. So I should have the 300 down here to designate my 300 students. And that's going to simplify to 1/6. So now I want to get the probability of being enrolled in English given that the student is enrolled in math. So let's take a look at that formula, and then we'll see how to solve it with the Venn diagram. So if I'm looking at the formula of being enrolled in English, given that I'm already enrolled in math, that is going to be the probability of being enrolled in math and English divided by the probability of being enrolled in math. So we can see from the numbers that we did before, that is going to be the probability of math and English is 50/300. And the probability of math is 100/300. Then we can simplify that to 50/100, which is 5/10, which equals 1/2, or 50%. Now, if you'll notice on your Venn diagram, we can do the same thing using the Venn diagram, where we take let's write this down, English given math. We have our formula, the probability of math and English, so that's the intersection, so we can just go ahead and get this 50 that's here in the intersection and divide it by the probability of the math, which is the blue. And then once again, that is going to simplify to 1/2, which is 50%. So now that we have identified that if a student is enrolled in math, then there is a 50% probability that they will be enrolled in English. Or another way of saying that is the probability of being enrolled in English, given the student is enrolled in math, is a 50% probability. So now let's reverse those conditions and find out what is the probability of being enrolled in math given the student is enrolled in English. And we'll use our Venn diagram to help set that problem up. So this problem is going to look like the probability of math given they are enrolled in English. So once again, that is the probability of math and English, or being enrolled in both classes, divided by the probability of being enrolled in our English class. So looking at the Venn diagram, we're going to take that green area where they intersect and divide it by the probability of the English, which is our yellow circle of 200. That's going to give me 5/20, which simplifies to 1/4. Which is 25%. So from these two examples, you can see that we can use Venn diagrams to simplify the amount of math and the amount of calculations that we have to do. You just want to put the information that is in each of your problems into the appropriate circles or intersections, and then from there you do the ratios of whatever it is that you're solving for. So just to review, this first one, we had the probability of being enrolled in English given math. So we took the probability of the intersection where we have both math and English, which was the 50, that's in my green intersection, and divided it by the probability of being enrolled in math, which was 100, which is in my blue circle. And that gave me a 50% probability that if a student is enrolled in math, they will also be enrolled in English. For my second problem, we took the probability of being enrolled in both math and English, which is 50, and then divided it by the probability of being enrolled in English, which is in my yellow circle of 200. That gave me a 25% probability that if a student is enrolled in English, then they will also be enrolled in math, 25%. Let's look at the next problem. On this one, it says on a college campus, 75% of the students own a laptop and 65% of the students own a computer. Of the laptop owners, 25% also own a computer. If a student is chosen at random, find the following probabilities. the probability of owning a laptop, the probability of owning a computer, the probability of owning a laptop and computer, the probability of owning a laptop given that you already own a computer, and the probability that you own a computer given that you already own a laptop. For this problem, we can also use a Venn diagram to help us solve it. You'll notice that it's similar to our previous problem, except for that with our previous problem, they gave us data numbers for each of the events, and this time they're giving us the probability percentages. So let's see how that changes our problem. The first thing we're looking at is we want to find the probability of the number of students that own a laptop. So that's right here. It says 75% of the students own a laptop. So that's going to answer our first question, what is the probability of owning a laptop? And we're going to go ahead and put that right here in our yellow circle and label that laptop. Our next question is, what is the probability of owning a computer? And the problem tells us that 65% of the students own a computer. So that answers our second question about the probability of owning a computer is 65%. We're going to put our 65% in the blue circle and label the blue circle computer. Now the next question says, what is the probability of owning a laptop and a computer? And that's going to be this green intersection where our two circles intersect, the intersection between owning a laptop and a computer. And we can see the problem says of the laptop owners, 25% also own a computer. Now this one, the way that it's worded is a little tricky, that if you're not paying attention, you're going to think that that intersection is 25%. But what that problem is telling us is that 25% of the laptop owners own a computer. So this is the intersection is not 25%, it's going to be 25% multiplied by the 75% of the laptop owners. So that's going to be 0.25 times 0.75. And that's going to give me 0.1875, which is 18.75%. So the probability of owning both a laptop and a computer is going to be 18.75%. So I'm going to put that here in the intersection, in my green intersection. So that's going to make solving my conditional problems a lot easier because now I've put my numbers into my Venn diagram. And if you'll recall, when I'm doing a conditional probability, I'm looking for the probability of the laptop and the computer divided by the probability of the computer. So that's going to be the intersection of the laptop and the computer, and that is 18.75% divided by the probability of the computer, which is 65%. I'm going to change those to decimals so I can do the math. And that is going to give me a 0.2885. So that means I have a 28.85% probability that if a student owns a computer, then they will also have they'll have a 28.85% of also owning a laptop. And our last problem wants to know the probability of, given that we have a laptop, what is the probability that we will have a computer? So that is the probability of the computer and laptop divided by the probability of the laptop, which is going to give me that intersection that's in the green, divided by 75%. I'm going to change those to decimals. Which is going to give me 25%. Now, if you'll notice, our problem initially told us that of the laptop owners, 25% also own a computer. So that is another way of saying that given that we have a laptop, 25%, there's a 25% probability that they're going to have a computer. So in this problem, instead of giving us the intersection, they gave us the probability, the conditional probability of having a computer given that you already had a laptop. I hope you have found this tutorial helpful. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos by Caz Academy. I'll see you at the next video. Thanks for watching.